I am going to give presentation on distance vector routing and its algorithms. Distance vector routing in a network, a node doesn't have the information about how far is it from all the neighbors. So gradual calculation of path by exchanging information with neighbors is done in network graph by using the algorithms. Each node constructs an array, an one-dimensional array containing distances to all other nodes and distributes it to its neighbors. That is, each node in a graph constructs path how far it is from all other nodes and sends its values to all its neighboring nodes. So the key thing to be noted here is that each node comes to know that how far is it from its neighbors. That is the cost of links to its neighbors. If there is no link between the particular two nodes, then the cost is considered as infinite. Suppose that there is a path from x to y via z. The cost of x to z plus the minimum cost from z to y is considered. It is that we can get from this formula. LHS is the cost of from x to y via z, and RHS is the first cost to go to z. Minimum cost to go to y to z is considered to get in shortest link with shortest cost, minimum cost. This is the two-dimensional array shown representation of how each node is how far each node from other nodes. Here a to a distance is 0. Distance from same node to itself is considered 0, and the nodes which are adjacent to particular node has a distance of 1, and if there is no link between the two nodes, then the distance is infinity. This is the routing table at the node A, where the cost from A to B is 1 and the next hop is considered B, and cost to C is also 1 because there is a direct link. Cost to D is infinity because there is no link between A to D, and similarly cost to E and F is 1 because there is a link directly connected between A and D and A and F, and similarly cost to G is infinity because there is no link between A and G. And each node sends a message to its neighbor with a list of distances. It is what to consider. We know that cost from A to C is 1. So in the previous slide, the cost from A to C, A to D was infinity, but here the cost from A to D is considered 2. How is it done is, the C sends the message to A that D is at 1 hop distance away from C, so A considered D is at 2 hop distance from it. Similarly, the cost for G from A is taken through F. This is the complete two-dimensional array showing how far each node from other nodes by calculating distances either directly or through other nodes. Routing tables should be periodically updated because the links can be broken or new links can be added. So routing table at each node should be updated periodically. Main reason is to let other nodes know that the sender is alive. If some routes refresh information that might be needed if some of the routes were to be unavailable. Trigger updates. When a node receives update from one of its neighbors, It lead to change in its routing table. Link failures. What happens when the link between the two nodes fail? How to detect the failures? One is to route updates don't arrive and probing with the test packets. Suppose in this graph there is a failure of link from F to G. That link from F to G fails, so the distance between F and G will become infinity. So it now sets the link cost from F to G to infinity. C learns that G is 2, but G is 2 hops away from C, but C is C is 3 hops G in 3 hops via C. Send update to F that F now can reach G via A in 4 hops. What happens here is when the link breaks from F to G, the node C knows that G is 2 hops away from C, and F knows that C is 2 hops away from F via A. So the node F get a new path, that is through C, F to A to C, C to D, and D to G. That's 4 hops away. Count to infinity problems arise when there is a node link, when there is a link between two nodes fails and there is no way to reach the particular node. So let us see in this graph. A discovered that link to E is lost. If before A's message is received, B or C advertise that they can reach E in 2 hops. See, B can reach E in 2 hops, C can reach E 2 hops. Those are the earlier updated tables through which B and C knows that it's 2 hops away from E. B gets A's update followed by C's update to say that E is reachable in 2 hops. So B tells A that A thinks it can now reach E via B in 3 hops. So in actual there is no way to reach E because the link is failure and there are no other ways to E to reach. And this loop continues. There is no stop for these links. To stop count to infinity, we should give a threshold value to maximum number of hops, but this will restrict the size of the network. Thank you.